Greetings, physics fans. Today we're going over a skydiving worksheet. We're going to include quite a few ideas about Newton's laws and everything related to it in order to solve some of these problems. So let's start by reading, of course, the top part. We've got a 90-kilogram skydiver jumps out of a helicopter at 6,000 feet above the ground. As he descends, the force of air resistance acting upon him continually changes. The free body diagrams below represent the strength and direction of the two forces acting on the skydiver at 6 positions during the fall. For each diagram, apply Newton's second law. We know the net force overall equals mass times acceleration to determine the acceleration value. All right, fair enough. Let's go from there and figure out what to do. All right, so our very first box here, box number 1, we're at 6,000 feet. That doesn't really do much for us, but we know that there is only one force acting on this diver right at the beginning. So overall, that force of gravity is 900 newtons, which means that the overall net force on that object, on that person, is equal to negative 900 newtons, or downward position, 900 newtons down. Now that I know that, and I know that this skydiver has a mass equal to 90 kilograms, all right, now I think I can use my equation, F equals ma, to solve for acceleration. So let me do that. If F equals ma, my net force is going to be 900, my mass is going to be 90, and my acceleration, I don't know, but I'm going to solve for that by dividing 90 to both sides. If I divide 90 out to both sides so that I can get A all alone, 90 cancels out, and my acceleration ends up being 900 divided by 90, which is 10. So overall, as the skydiver just jumps out of the helicopter, the acceleration is going to be 10. Now remember, this is a net force of negative 900. So easy thing to do, but don't forget about that negative sign there on the 900. So technically this is a negative 10 meters per second squared. And you know what that is? That's the acceleration of gravity. Remember, we usually say that gravity is about negative 9.8. This is just rounded to make the worksheet a little bit easier. But because of the Newton's second law, F equals ma, we were able to figure out that the acceleration was negative 10. All right, now that we did that, let's go from there. So as soon as he jumps out of the plane, he's in complete free fall. Now, not so much. Now we've got air resistance and gravity working against each other. So if we know the net force, the overall total net force is going to be equal to our positive 200 upward air resistance plus our downward negative 900 newtons. Overall, what does that mean? My overall net force is going to be equal to negative 700 newtons. Now that I know that, can I plug into my equation and solve? Yeah, absolutely. Because we know that F equals ma, my net force. So my net force, F net, is going to be equal to mass times acceleration. Net force we just figured out was negative 700. My mass is 90 and my acceleration is A. All I have to do, just like I did with the first part, was divide 90 over into the negative 700. And what do I end up getting for my acceleration? But negative 7.78 for my acceleration. Now take a look at that. Originally we were accelerating at negative 10 to start. Now we're at negative 7.78 meters per second squared. But that makes sense. We're still accelerating down, speeding up, but not as much because air resistance kicked in. Now let's look at 4,500 feet and look at that. Up and down forces, 900 and 900, even each other out. So if you think about the net force, which is sigma F, it's going to be 900 plus a downward negative 900, which equals 0. Well, what do we know about F equals ma? If net force is going to be 0, then what does the acceleration have to be? Well, it's going to definitely have to be 0 as well. Think about it. If net force is 0, then this side's going to be 0 as well. So F equals ma is going to be 0. Does anyone know what we call this when up and down force is equal when we're falling out of a plane or that? It means we can't speed up anymore because we are not accelerating. Acceleration is 0. So we've reached what's called terminal velocity. All right, so we're free falling and we're falling through the air. Now let's zoom up towards the top here and take a look at what's going on with this gent. And it looks like the parachute is about to open. So wow, because of that, we know the parachute catches air and increases the air resistance or the friction of air, right? So force of air is there. We know that net force overall is going to be equal to an upward 1100 plus a downward or negative 900. So what does that mean? Overall, your total net force is going to be equal to 200 newtons. Now that we know that, can we plug in for net force, 200 newtons, to solve for acceleration? Sure can. We know net force is equal to mass times acceleration. So this is going to be, sorry, I wrote off the page there. 200 equals 90 times A. Divide both sides by 90 to get A all alone. That becomes 200 divided by 90, which ends up being 2.22 meters per second squared. What does that mean? It still means that we are accelerating, but we are accelerating with the direction of the acceleration upwards. So what does that mean? That means we're slowing down because we're falling downwards, right? Velocity is down, but acceleration is positive, which is up. And we know for a motion, when velocity and acceleration are opposite each other, that means we're slowing down. Is that a good thing? Yeah, guys, we're falling out of a plane. We definitely want to slow down. All right, so now that parachute is wide open. Yes. So we've got 1,500 for an upward force, and of course, gravity's force is still 900 newtons down. Take a look and pay attention that it's the same throughout. Force of gravity is always pulling equally. So let's go over that net force, which is sigma F, and I could write that a little nicer for you guys. Sorry, let's do that again. Sigma F is net force is equal to upward 1,500 plus a downward or negative 900. What does that give us? That gives us a net force of 600 overall. Okay, so if I know my net force is 600 and I'm solving for acceleration, F equals ma, looks like I've got 600 for my net force in the upward direction. Mass is 90, acceleration is a. Let me divide both sides by 90 to get a all by itself. And acceleration becomes 600 divided by 90, which is approximately, in my calculator, 6.67 for the acceleration. Now, what does that mean? Remember, since this is positive, the acceleration is in the upward direction, but you're still falling. So velocity is down. So that means, are you speeding up or slowing down? That's right, you're slowing down yet again. So that's good. We don't want to fall too fast when we fall out of an airplane. All right, let me clean up this side so that we can do our very last one. And if you look, it looks like upward and downward forces equal out. So if I do the net force overall, it's going to be 900 upwards plus negative 900 or 900 force downwards. That equals 0. Remember, the net force is equal to our mass times acceleration. But if net force is 0, even if we still have mass, whatever we divide into 0 is still going to be 0, so my acceleration is 0. And once again, we reach terminal velocity. That's when your force of gravity down is equal to the air resistance up. Awesome. This person is coasting, no longer speeding up. I actually felt that when I went skydiving. I jumped out of the plane. You feel that crazy acceleration in your stomach, that falling feeling. But as soon as we opened the parachute and got to the same terminal velocity, meaning the same upward and downward forces, I no longer felt it in my stomach. It was like we were just floating down. It was super calm and peaceful and beautiful. Totally recommend skydiving for any of you that feel like it's something to look into. I really enjoyed it, but not for everybody. All right, now that we've done that, let's take a look at our questions. Number one, at which two altitudes has the Skydiver reached terminal velocity? We already said that, right? The two elevations where they reach terminal velocity, meaning that it can't speed up anymore. It's at no acceleration, constant velocity, 4,500 and 1,500 feet. So let's make sure we put that in there. 4,500 and 1,500 feet. Be sure to write that. If we look at question number 2, at which altitudes is the Skydiver in a state of speeding up? Remember, if we are speeding up, that means that our acceleration and our velocity should both be going down. So let's take a look at that. If I'm speeding up, my velocity and acceleration should be going down. Speeding up means then that it should be the two accelerations that are negative. So that is going to be at 6,000 feet and 5,500 feet. So make sure you write that down, 6,000 and 5,500 feet for your question number 2. If we take a look at question number 3, at which altitude is the Skydiver in a state of slowing down? If we are slowing down, that means that acceleration was up while velocity was down. Remember, your velocity is down the whole time. You're falling the whole time. You never float up or anything. You're always dropping. But acceleration changes when you open up that parachute because now acceleration is working against you. So let's look at where the accelerations were positive. And it looks like here and here is where they're positive. So at 3,000 feet and 2,900 feet, looks like when you could answer that question for number 3. All right, let's take a look at the next one. At 2,900 feet, the Skydiver is blank. All right, let's look at 2,900 feet. 2,900 feet is right here. We have a positive acceleration, so acceleration is up. But don't forget, you're always falling, so velocity is down. So if acceleration and velocity are opposite each other, does that mean speeding up, slowing down, or staying at a constant velocity? And it would be slowing down. Good. Let's talk about number 5. Explain why air resistance increases at 600 feet and 4,500 feet. Okay, let's look at 6,000 and 4,500. I think I said that, 6,000, Ron. All right, looking up here at the top, 6,000 feet. Our question originally was explain why air resistance increases. So we are going to fall out of the plane, and as soon as we fall out of the plane, before we get moving, we feel the force of gravity, but there's no air resistance yet. After that, air resistance is going to increase because as we fall, we're going to fall through the air, which means the air is going to push on us. So we're speeding up, the air is going to push more and more on us. Now, the other question was for at 4,500 feet. So let's look at 4,500 feet. Air resistance increased, again, even more to 900. Why? Because the faster you fall, the more that air is going to push on you. So therefore, think about how you want to answer that question for number 5. The faster you fall, but the more air is going to push on you. And how come air resistance decreases from 2,900 to 1,500 feet? Okay, let's take a look at 2,900 to 1,500 feet. 2,900's there, 1,500 is there. Well, I think it's the same idea. When you just open the parachute, there's definitely a lot of air resistance. But as you go slower and slower, that air resistance is going to let up because the parachute is doing its job. So when you think about question number 6, explain why air resistance decreases. Well, we know as we get slower, the air resistance isn't going to push on as much because we're not falling through the air as much. All right. So physics fam, man, we went through a lot here, but this was highlighting Newton's second law. The idea that you have to have a net force, and remember, net force is either sigma F or F net, but you have to have a net force in order to have acceleration. So that's why this equation, net force equals mass times acceleration, works. We figured out, since we had the mass, what the net force is. Once we knew the net force, we could plug in, chug out our acceleration, and we went back to the kinematic rules. Remember that if your velocity is down and acceleration is up, you are slowing down. But as you're falling, if velocity is down and acceleration is down in the same direction, that means you're speeding up. All right, nice job today, physics fam. Hang in there, and thanks for listening. Feel free to reach out during class for any questions.